DHCP management. In this nugget, we'll discuss DHCP management, whereas in the last nugget, we talked more about installation and configuration. Well, when it comes to management, one of the first things you want to understand is that you'll have the proper redundancy in place, because you don't want a DHCP server to go offline and then have no way of issuing addresses. So we'll discuss that, as well as how to manage the scope. You don't want to run out of addresses either. So there's some things we can look at, especially with things like RAS servers that we can consider in terms of helping to conserve the addresses, to configure the proper lease duration and things of this nature. We'll also take a look at the server properties, which has a lot of important configuration settings, one of which is dynamic update, because there are several places you can configure dynamic update, and this is where your clients will register their own host records by default, if they're Windows 2000 or later, and where the DHCP server will register the pointer records in DNS. And there are variations on that, but we'll take a look at the settings that are available. And then DHCP database management is critical as well. You can look at how to reconcile the database. This is going to be critical if you have errors in the database. We'll also take a look at the logs, which aren't the database themselves, but a reflection of what takes place in the database. And we'll take a look at how to back up and restore and compact that database. We had to start this nugget off with a discussion of redundancy for DHCP. I mean, what if this is my only DHCP server and it goes down, and then I got some salespeople coming in with their laptops and they're coming in for a big meeting, they all try to get on the network, and everybody's getting a 169.254 address. Well, that's going to be a big problem. So I would like to have an additional DHCP server on the network. Now that introduces another problem. We'll assume, first of all, however, that we're having a single segment and two DHCP servers on that single segment, just for simplicity's sake for now. Now, it does introduce this problem, though, and that is, I don't want both DHCP servers potentially attempting to give out the same IP addresses. Now, they will resolve that. They will detect conflicts and everything, but it's going to result in a lot of ARP broadcasts and a lot of going back and forth and a lot of negative acknowledgments or NACs and all that kind of stuff. So I want to make sure that this goes as smoothly as possible. And what I'll generally do for that is to use something called the 80-20 rule. Now the way I'll do that is I'll have an additional DHCP server, which offline and off screen here I've already installed, but I have not authorized or configured it with any scopes. And I'm going to configure it with a portion of my existing scope here. And I'm going to change my exclusion here. So if this server, DC Nugget 1, is the one I want to lease 80% of the addresses, then I will exclude 20% of the addresses from being leased out here. And I'll just change this exclusion range, actually delete it and recreate my exclusion. And then on the other DHCP server, which will be DC Nugget 2, and also I'll show you that in the same interface here shortly, on that one I will allow it to lease only 20% of the addresses. And that way, if this main DHCP server goes down, at least I have something else to kind of fill in the gap while I replace a hard drive or fix the hardware, whatever else it was that I need to fix on this particular server. So what I'll do here first is I'm just going to delete this exclusion range, and then I'll create a new one. But I got to figure out what it is that I want to be able to create here. First of all, we still want to exclude those first 20 addresses. So with 234 addresses left, let's go ahead and crack open Calculator and take 234 times 0.8. So 80% of the addresses would be 187 addresses, and we'll just round down from there. Okay. So with 187 addresses, and let's just take my 234 minus 187. That would mean that I want 47 addresses left for my 20% remaining. So then on this server, 187 addresses for the 80% portion, and 47 addresses on my other DHCP server for the 20% portion. So then, I still want to exclude those first 20 addresses to reserve those for my static IP addresses, for my servers, for my printers, and that kind of thing. So I'm going to take those 20 addresses plus the 47 addresses that are going to be in the scope of my other DHCP server. So that's going to be a total of 20 plus 47, 67 addresses, and I'll create a new exclusion range to reflect that at 10.10.10.1 through 10.10.10.67. And I'll add that up, and then I will close. And now I'm excluding my first 20 plus my first 20 addresses plus my first 20% of the addresses remaining for this particular scope. Now then, that's going to be working just fine. Now this DHCP server from this point on, its first IP address that it can lease out will be 10.10.10.68. Now, we don't need to resolve this immediately, but also recall that my first reserved IP address is 10.10.10.23. Remember, under my reservations here, that's going to cause a problem because at this point, whenever this client tries to renew this address from this point on, it's not going to be able to get that address anymore because it's now excluded. So just be aware of that. in the future, and I would have to actually delete that client reservation and create a new one in the appropriate range that's not excluded here. Either that, or if I do want it to have that address, then I'll have to configure that reservation over on my other DHCP server, which I haven't configured quite yet. So let's go ahead and go to that other server. Let's right-click on DHCP, and then I'll choose Add Server. At this point, I'll enter in DC Nugget 2. And we see that we have DC Nugget 2 down here, which, as I mentioned earlier, is not even authorized yet, but that's okay. And then next, let's just go ahead and create the scope. And again, we will exclude 80% of the remaining addresses out of our 234, and we'll allow it to use 20% of the 234 addresses. Now, I've already gone ahead and created the scope here. Since we've already done that in the past, you already know how to do that. I didn't take you through that again. I just did it offline. And now I'm going to add the new exclusion range here, which I'm going to have to still put in my exclusion that I want in all cases, and that would be my first 20 addresses that I want for all of my print servers and things of this nature. And then I'm going to exclude the remaining 187 addresses here as well. So I'm going to go to 10.10.10. Remember, 68 would be the first address that's going to be used on the other DHCP server, and I don't want to duplicate that over here. And I'm going to finish this at 10.10. If I can type 10.254. Okay, so we got 10.10.10.68 through 254 excluded now, and then we'll add and close. And if you check this out, then we've got 1 through 20 are excluded, 68 through 254 excluded. That covers the entire leasable range on this other DHCP server. And that leaves us then with DHCP addresses of 21 through 67 available on this DHCP server. And then, of course, all that would remain is I'd have to authorize this server like I did the other one by right-clicking and choosing Authorize. And now I have 2 authorized servers ready to lease out addresses. Now, especially if you're coming into an environment where it's not your network, you're a consultant and you're trying to find the DHCP servers and you don't have the information you need, for example, then you could go to a command prompt to locate those servers. What you could do is to do net shell, which is another command line command that you can use to manage a lot of different services. One of those is DHCP. And I could do a net shell DHCP show server, for example. And that would show me that it found 2 servers in directory services. So it found 2 authorized DHCP servers. So if I had any rogue DHCP servers like NT4 servers or any older, maybe Linux servers or something like that, then they would not be listed in this even though they would be on the network. But my authorized servers, it does show me what they are, so that's kind of a handy tool to use. Now, as long as we're on the subject of other DHCP servers, let me also show you DHCP loc, which is a command line utility that you can use to identify rogue DHCP servers on the network. And it's not quite as automatic as it might look initially. Here's what happens, really. DHCP loc can be configured with additional parameters, and you can look at online help if you want more detail about that. But one of the ones would be you could set up alerts so that it would issue them every few seconds to any given machine that you wanted it to, so that you could see pop-up messages and the like. And then here we identify which server we're actually running DHCP loc on, 10.10.10.20, and then we identify our DHCP servers. .20 is the first DHCP server, .22 is the second DHCP server. I'll just press enter, and now it kind of keeps an ear to the network to see if it can detect any IP traffic going on in terms of DHCP. So on an offline computer, rather on a computer that's not outside of our view right now, I'm going to go ahead and renew an IP address. And then we'll go ahead and see here that it's going ahead and offering an IP address. That's where it is right there. It's offering an IP address of .69 from the .20 DHCP server. It's acknowledged 69 as well, meaning that that client has indeed successfully leased that address. Now, if I quit this, then let me just kind of simulate what it would look like. You just press Q to quit, by the way. Let me simulate what it would look like if we were finding rogue DHCP servers. If I had left out that one of my DHCP servers was 10.10.10.20 here, and not manually entered it in as one of my authorized DHCP servers, then what would happen is when my other clients attempted to renew an IP address, and I'll do that offline here, rather away from the screen, I'm trying to renew an IP address, then since I didn't enter that in as an authorized server, it thinks that it's a rogue DHCP server, and it lets it go ahead and do its thing. It's not going to stop it from leasing any addresses, but it does notify me that it thinks that it's a rogue DHCP server by giving me these asterisks out to the side here. Notice that it also only gives me the offer and the acknowledgement. That's because it's not tracking the discover and the request packets, because it's only trying to identify DHCP servers that are spitting out these packets here, and that's all we're really looking for. Now, I've also simulated another thing that could happen here, and that is when you run out of IP addresses. Here we have the exclamation point on the blue field here on both the server and the scope, and that means that this scope doesn't have any IP addresses that it's able to give out. Now, if I look at the address pool, see that offline here, I've actually excluded everything. So that's why there's no addresses going out, because I've excluded the whole thing. Now, that just kind of simulates what you'll see when you get these little symbols on there. And also, if you had actually leased addresses and you'd leased out all, 200 and some addresses or whatever it is that you're leasing out here, then when you go back to the server up here at the top, and let me scroll over, then you will see off to the right here another message that says error 14. Error, E-R-R-O-R, 14. And that simply means that you have leased out already, actively leased out, all of the available addresses from your scope. Now, another real handy thing here is if you go to the server, and I'll go to DC Nugget 1 here, which has been my most active DHCP server, and click Display Statistics, gives you some interesting information about it, how many discovers and offers have been made. I would want to really especially keep track of how many declines or negative acknowledgments or knacks it has made, because, 2 is not too many, but I want to see if it's denied a whole bunch of different ones, which might mean that I have another rogue DHCP server on my network that's handing out duplicate addresses or something like that. Also very handy is to see how many addresses are in use and how many addresses are available. And this is something you want to keep track of, especially as the network grows, to make sure that you're not close to depleting the available addresses you have available. Now, here's an example where I might be running out of addresses and I need to use something called a super scope to be able to fix it. You see, we start off with all these clients on the network, and let's just say this represents, 100 computers here. So I need about 100 addresses plus my static addresses and all of that. And we're using a Class A network, and that's 10.10.10.0, but we're using a Class C subnet, so it's effectively a Class C, and it's only good for 254 at the maximum addresses. Well, now we merge with another company, and we add 300 more clients, so now we've got a total of 400 clients that are going to be coming into this network, and I want to plan for that, so I know that I'm not any good with just this one physical subnet and a single logical network over here. Well, the purpose of a super scope is where I'm going to be able to use a multi-net, and that's where I have a single physical network with multiple logical subnets. And here would be my second logical subnet for a second 254, which would give me, of course, a total of 512 IP addresses that I could use on this network, more than enough to cover my 400 here. And then the actual implementation of that would be done in the DHCP console, where I've already removed my other DHCP server and I've set things back to where we originally were, where I've just got my original exclusion of the first 20 here. And then what I need to do is to create another scope, and this is my additional scope now, but I do not yet have a super scope. What I have to do after I've created this scope with the same options that you can see right here is to go up here to this server and right-click and choose New Super Scope, which starts, of course, a wizard. Big surprise here, right? So we click on Next, and then we just call this whatever we want it to call it. We'll just call it Nugget Super Scope, for example, and Next. And then we specify which scopes we want in this. And that's why I have to create the scope in advance, because otherwise there won't be anything that appears here. So I want my .10 and my .11. So if I hold down Control, then I'll be able to select both of these by clicking on them, and then clicking on Next. And then that's pretty much all there is to it. I've now created a super scope, which is comprised of 2 separate scopes originally. Now, when it comes time to decommission this super scope for some reason, I can just right-click here on this scope and choose Remove from Super Scope. Or I could just delete the super scope itself and right-click here and choose Delete, at which point it's going to delete the super scope, but it'll leave this child scopes here intact. I'll just go ahead and say yes for now. And that gives me back my separate scopes here. And I'm going to go ahead and delete this one because I'm not actually going to use that one. I'm just going to stick with what we originally had up here. Now, when we go back to our scope options, let me show you another thing that I can point out in terms of conserving addresses. And that would be where perhaps I've got a RAS server. And we call them a RAS server, but it's really a routing and remote access server. And Microsoft calls those RRAS, or just the full name now, routing and remote access servers. We talk about that a lot more in the same series. But in any case, the routing and remote access server, let's say it's got 10 VPN connections that it will be able to service. Well, what it does is it will lease 10 IP addresses from my DHCP server in advance. And then it'll hold on to those IP addresses, even though my clients on that RAS server might not need them for that long. So what I could do is to configure an additional scope options by right-clicking and choosing Scope Options and going to the Advanced tab. And then I could go to Default Routing and Remote Access Class, and I could set a shorter duration for those IP addresses that are going out to the RAS server. So I'd go down to option 51, and you don't need to memorize all of these because many of them are very obscure, but this is one you might want to be aware of. And this would change the lease time instead of my default 8 days to whatever I specify here. For example, if I wanted it to be 1 day, then I would have to configure that into the number of seconds. So that would be 24 hours times 60 minutes per hour times 60 seconds per minute, and that would be a total of 86,400. And I'll copy that using Control-C, and then just paste it in down here. Once I've pasted it in there and clicked OK, notice that it automatically converts it to hex format, so you don't have to do any hex conversion or anything like that. Now I went ahead and deleted that 51 option because I'm not going to actually use it. But now another option that I could use instead of just that is I could also configure a static pool of addresses on the RAS server. And then I would just not use that range of addresses that I'm using on that RAS server in my address pool here. So I would just start at a higher number, for example. Or I would add an additional exclusion for whatever it is that I am using on that RAS server. Now another scenario might involve something like mobile users, where I've got maybe a whole crew of salespeople that come into the office, and I got dozens coming in every day, but they're not in my office every day. They're in different offices throughout my state. So when they come in, they lease an IP address, and they show up in the IP address leases here. They're going to lease it for 8 days by default, but I might not see them for a couple of weeks again. Well, while they're gone, their address is still listed in here as unavailable to any of my other clients. And if I start to run out of IP addresses, it might be because I have a lease duration that's too long, so I could right-click on the scope and go to Properties and adjust this so that I might make it, a day. Now, of course, that also means that I'm going to get a lot more DHCP traffic going on because each one of my clients is going to try to get a lease renewal at 50% of that, so at every 12 hours, and I'm going to get more traffic that way. But if my network can bear it, I can just change it to a lower lease duration there. Or I might even compromise and make it 4 days to give myself a balance between additional traffic as well as not depleting my address range. Now also, let's take a look at the server properties by right-clicking and choosing Properties. And from here, we get into a whole bunch of different things that we can configure. First of all, you can automatically update statistics on your DHCP server every certain number of minutes. That's what we see here when we right-click and choose Display Statistics. I could just leave this running and keep it viewable for as long as I want to. If it doesn't update automatically, then I have to manually hit refresh whenever I want to get an update of these statistics. Otherwise, if I go ahead and automatically update them, then it'll update every 1 minute, for example, like I've got here, or something like that. Then we can also enable DHCP audit logging. That will give me log files to look at that are named according to the days of the week. I recommend you leave that checked so you can check to see if there's anything strange going on with DHCP for troubleshooting purposes. And then you can show a bootp table folder, which will add an additional node to the DHCP console here, and which will allow you to manage bootp in terms of your bootp routers. Now, in the DNS tab here, this is going to relate to the advanced TCP IP settings that you see on a current Windows operating system, which again is Windows 2000, XP, Windows Server 2003. For all of those operating systems, there's a default checkbox that will register the connection's address in DNS, provided that DNS does support dynamic updates. And these are also all default settings, and what happens is any of those current Windows operating systems will automatically register their own DNSA records, but they will request that the DHCP server register the pointer records for them. And so it's being requested by the DHCP client to register the pointer records. That's exactly what it does. And you can also take the burden off of the clients and put it all on the DHCP server by always dynamically updating both the A and the pointer records. And if you have any down-level clients like Windows 98, NT4, something like that, they do not know how to automatically request their own registration in DNS. They're not capable of doing that. So for those older clients that you might have on the network, you'll need to check this box if necessary. And then what we'll also have, and I'm going back to our default settings here, what we'll also have is the ability to discard A and pointer records when a lease is deleted, and that'll prevent us from getting stale resource records in our DNS server that we would otherwise have to manually go through and figure out which ones are old and which ones need to be cleaned out. This will do it for us automatically that way. Now on the Advanced tab, we have a pretty important setting here, and that's the conflict detection attempts. You see, what would happen if we had two parts of our company that came together? Maybe we merged our Toledo office with our Phoenix office. Well, in both offices, they use private IP addresses of 10.10.10. IP addresses. So now when I move all those machines down here and get all my laptop users down here and everything like that, they might have leases still from that old Toledo office. So when they come up on my network and do a renew, what's going to happen is the existing DHCP servers will say, oh, you want 10.10.10.20? You can't have that. Somebody else has already got that. And so you're going to get a knack, and you're going to get a lot of back and forth traffic with trying to renegotiate a new lease. Well, what you can do instead, if you have that kind of scenario, is to configure a conflict detection attempt. And I might enter in a 1 here. What happens then is before it actually gives that IP address to a client, it'll first ping an IP address that it's trying to issue. And then if it gets a reply back, it'll say, oh, somebody else has already got that address, so I'm not even going to offer it. Let's try some other address. And that's what the conflict detection attempts will do for us. You probably don't need to enable this or to put a number in there unless you know you're coming into a situation where you're going to have a lot of clients coming in that might have duplicate IP addresses. Another thing there would be, I don't see where you would need to do this any more than once. I mean, you could put in, 2, 3, 4, 5 if they're in there if you want, but that's a little overkill. I mean, if you can't ping it after one attempt, chances are you're not going to be pinging it at all. So I would usually just enter in the number 1 there. And for these other settings, for the autolog file path, the database path, and backup path, you see that you can specify different locations for all of those. The only one that you probably would have to put in a different location in certain cases would be the database path, because if you have a very busy DHCP server, it's very disk intensive, according to what Microsoft says, and Microsoft actually recommends that for busy DHCP servers, you offload that database path to a different spindle, and preferably a SCSI spindle that's able to handle high disk throughput. And then for our server bindings down here, when you click on that, that shows that we're connecting this DHCP server to 10.10.10.20, and the only reason why it's able to do that is because I configured a static IP address for that .20 address. And without that, it would not be able to bind to this, and that's where I was telling you earlier that you couldn't even be able to open the DHCP console and manage it with a dynamically configured address. It won't even let you, because it can't bind to a DHCP server. As far as credentials is concerned, you can enter in a username, domain, and password for a specific account that you designate so that it becomes the owner of any records that are created within DNS. Now, you might recall that when we went to the properties of the DHCP server here, we had a DNS tab, and we discussed all these settings already. But as I was looking at that, you might have thought to yourself, wait a minute, I thought that was on the scope. So if I right-click scope and choose property, yeah, there's a DNS tab, all the same settings. Okay. You notice that there will also be the same tab if I go to the reservations and go to its properties. There again is DNS. Well, there's an order of precedence just like the options for DNS. And the order of precedence is the lowest order would be the server, which would then be overruled by any scope DNS settings, which would then be overruled by any reservation DNS settings, provided there's any conflicts within any of these. Now, another thing you have to be careful of is that when a client sends out a DHCP Discover broadcast packet, it eventually gets an answer, and it's able to release an IP address from the DHCP server. Now, here I've got two subnets, 10.10.10.0 and 10.10.11.0. Now, on this side, these clients will be able to send out a Discover packet, and they will get listened to by the DHCP server. The server will send back and complete the DORA process. However, over here, I have a routing and remote access server. And the purpose of the routing remote access server is just like a hardware router in this configuration, so that it's going to block broadcasts from one network from passing over into the other network. That's its job, so that it can cut down on broadcast traffic and not unnecessarily propagate those broadcasts. However, this client here, poor guy, is issuing a DHCP Discover packet. Now, if it's issuing this DHCP Discover packet and this RAS server is configured to just block the broadcast, then this guy's never going to get an IP address, and I'm going to get all 169.254 addresses over on this side. We don't want that to happen. So what you can do with an RAS server is you can also add in an additional protocol known as the DHCP relay agent. Once that's configured, this RAS server will listen for any DHCP broadcast Discover packets, and then it will say, oh, hey, I'm supposed to listen for that and pass it on. So then it will pass it on using a directed send to the specific IP address of this DHCP server. Along with that directed send to this DHCP server is an identification for which network it comes from, because this RAS server has two network cards in it. One of the network cards comes from this IP address range, and the other network card comes from this other IP address range. So when it forwards that packet on, it identifies itself as having belonged to this side of the network, and then the DHCP server, when it creates an offer for that DHCP Discover packet, it's going to send back an IP address within this range, and that's how we can make sure that we get the proper range of addresses on one subnet and on the other subnet as well. And then after the offer comes back, the rest of the DORA process continues as usual. Now, I've also talked about boot P routers, and if you had a physical hardware router in here instead, I'll just put in a physical hardware router. It may also be boot P compatible or boot P capable, and that would be a router that's capable also of doing a similar kind of function as a DHCP relay agent and passing on requests for a DHCP server and allowing DHCP offers to come back through the router back onto the clients. Now let's go ahead and address how we would configure a routing remote access server to use the DHCP relay agent. Now as you've seen, a lot of the topics we talk about here in DHCP have a lot of involvement in other network technologies, which we'll also cover throughout this nugget and throughout this series. And one of those, again, is routing and remote access. And so for right now, let's go down to routing and remote access where I've already configured it. We will show you how to do this from scratch later on in our series. But for right now, you see that I've got a routing and remote access on DC Nugget 1. And under routing and general is where I'm going to go ahead and put in a new routing protocol. So I right-click here, choose New Routing Protocol, and select the DHCP Relay Agent and OK. Once I've done that, now I've got the DHCP Relay Agent here, and I need to configure which interface it's working on. So I'll right-click here, choose New Interface. Maybe it's listening on local area connection here. And then I will get a couple of options here, which I'm actually going to come back to in just a moment. So let me OK past this for now. First, I want to go back to this relay agent, though, and go to its properties. And here we'll have the IP address for the server that we want to forward the packets onto. So that would be, for example, 10.10.10.20 as the IP address of my DHCP server. And OK. And that's what's going to happen now when it listens on this network card and it hears a DHCP Discover packet. It's going to send it on to that IP address I just entered. Now, if we go to the properties of the local area connection, which I just looked at there, then we will see that it indeed is going to relay the DHCP packets. I can disable this, which kind of defeats the purpose of even having it here. But we will relay the DHCP packets. Then we'll have something called a hop count threshold. You see in the old illustration that I showed you just a moment ago, it was going one hop through that one RAS router onto the DHCP server. But we wouldn't want to get ridiculous so that it was going from 5, 6, 7 hops all the way around my network until it finally went through enough routers to reach the DHCP server. That would probably just be bad network design, and I would probably need to put more DHCP servers on other subnets in order to avoid so much hopping around. Because too many hops will result in possibly a performance penalty as well as excessive traffic that might not be necessary. So we could reduce this and say, you know what, let's not be ridiculous. Let's make sure that if it doesn't reach it in 2, it's not going to reach it at all. Something like that. Then we could also do a boot threshold in the number of seconds. I could set that up. Usually you'll set this fairly low. I might set it up at 1 second. That means that before it passes on the packet, the DHCP Discover packet, as a directed send to the DHCP server, it'll wait 1 second. Now, why might it do that? Perhaps there's more than one DHCP server available, and we want to give preference to other DHCP servers, so we're going to hold up traffic for 1 second coming from this interface and in favor of allowing other DHCP servers to respond first. Let's go ahead and talk about housekeeping now, because there's a lot of different things you need to work with on a DHCP database. They're not overwhelming, but administrators do need to periodically look at some of these things. Number one, remember in our DHCP properties, we looked at the fact that you can store DHCP database logs elsewhere on the server. So we'll go to Windows, System 32, and having gone to System 32, you'll see that there's a DHCP folder here where we have both our DHCP database itself, and notice that I only had 3 or 4 leases really going on there, but it starts off a full megabyte in size. And then we have various other kinds of information here, various types of files, but what we're interested in right now are the logs themselves. And if you crack that open, the first 50 error message types or event IDs are identified here. The common types are identified. Anything above that would be reserved for rogue server detection information, so you might see something above 50 for that purpose. Now, otherwise, we'll see pretty common messages. For example, we saw number 14 here. I mentioned that earlier, that you'll see in the actual DHCP interface itself if the scope's address pool was exhausted. Now, hopefully, the rest of what you see here will be pretty clean. In our case, we do see some denials and some stuff like that because we deliberately had some conflicts so that I could show you some things like the bad address here with an IP address that was already in use on the network. It shows us the MAC address of clients that are attempting to obtain IP addresses, whether or not they released them, whether or not they deleted them. All that kind of stuff is all through here, and it kind of helps you to put in one location a compact view of all that was going on with this DHCP server. And you saw there that also those log files are named according to the day of the week, and of course that means you can keep up to 7 of those. Now, let me also point out that you might get inconsistencies in your database as well. You see, the DHCP server maintains a database, a JET database is what it is, and it will have 2 types of information in the database. One is detailed IP lease information. The other one is summary IP lease information. And the 2 should be in sync or should agree with one another. If they don't, that's probably because of corruption in the database, and you might be able to easily fix that simply by reconciling either an individual scope or all the scopes on the DHCP server. To do that on a scope basis, you simply right-click on the scope, and then you simply choose Reconcile. At this point, you'll click Verify, and if there are any problems with the consistency here, it'll give you a message here, and you'll be able to identify what the problem is. Also, you could do it on a server basis by right-clicking here and choosing Reconcile All Scopes and Verify again. And of course, we're having no problems here, so we don't see any error messages. But if you do see errors pop up in event log or any pop-up windows that mention something about a corrupt DHCP database, that's one of the first things you can do is to perform a reconciliation. Now also be aware of the fact that the database, the Microsoft DHCP database, even though it ends in an MDB extension, is not an Access database, so you can't just crack it open in Access. It is, however, a JET database, and part of the meaning for that is that the Microsoft operating system here will have capability to perform compaction on the fly and while the service is running, and it does this periodically on its own to help conserve the space, to make it more efficient, and to make it more reliable. However, if it gets to be inconsistent or you suspect any problems with it, and there's troubleshooting issues, first thing I would do is to reconcile the database first. Once you've done that, then would also compact the database manually. In order to do this, you need to first stop the service. So I would go up here, and you can right-click here, All Tasks, and then Stop. But let me also show you the command line way to do this, because this might be handy in batch files or something like that. You could do a net stop DHCP server, and then that will stop the service. The next thing I would do would be to change directories to Windows, if I can type, Windows System 32. Wow, I'm really having trouble typing today, and then DHCP. Okay, so once we get to this, then the next thing I would do would be to go ahead and jetpack the DHCP.mdb database, and then I also want to put in another file here. That will be a temporary file. You can name it whatever you want. I'll just go tmp.mdb. What's going to happen is it's going to pack this database into more or less kind of contiguous space in this temporary database over here. Once it's packed it into there more efficiently, then it'll copy all the data back over to the original database. And I'll just press Enter to let it go ahead and do its thing. And we see that it did successfully move it back from the temporary file over to our permanent actual DHCP database. Now once it's done that, I can do net start DHCP server, and we're back in business again. And you can see how you could easily add all this into a batch file if you wanted to do it automatically without any human typing like I do, which is pretty horrible, as you can see there. Now also, you should compact the database manually like I just did if the database gets to be about 30 megabytes in size, and that will help to be more efficient and help to avoid more troubleshooting problems in the future. Now also be aware of the fact that the DHCP database backs itself up automatically every 60 minutes, which is what we call a synchronous backup. The purpose for the synchronous backup is so that it can repair itself if it detects any database corruption. However, if it's very serious database corruption and you need to get back a good copy of the database from a manual backup, you can do a manual backup as well, which is also known as an asynchronous backup. Now using that, you'll just right-click on the DHCP console and back up the entire database. Now only backups that you perform manually are available to restore the database as well. So if you want to perform a manual restoration, you have to have a manual backup that you've created. And the information that's included in the database backup will be any scopes, any reservations, any leases, and any options that you have configured. So then let's go ahead and perform the backup, and to do that I'll right-click on this server, and then I'll just simply select Backup, and then I'll designate the backup location. It's already got a backup location configured. This was something else that we also configured in the default properties of the DHCP server. I'm okay with what we've got, so I'll click OK. And now if I go to the file system and I can locate that backup, which is again under Windows, System 32, and DHCP, then I'll see that I have my backup folder here and a DHCP CFG file. That is my actual backup of the DHCP database. Now, if I detect any problems with my DHCP server at any time, I can simply right-click here and choose Restore, and restore the backup from the original location that I had here. It has to stop and restart the service. I'll simply click Yes to allow it to be able to do that. And then once the service starts back up again, we should be in business. Again, I would just, as a precaution, also reconcile the database, reconcile all the scopes, just to verify everything's okay, and we see that everything is. Now, a couple of other purposes for creating that backup. I could have a hot spare. So, for example, I got DC Nugget 2, which you see now I've taken all the scopes and everything out of it. And I could take that server and make it more or less a hot spare. That means that I would take my backup, if this server ever had a problem, and I would take a backup from my tape backup, where I'd already backed up Windows System 32 DHCP's folder and all of the backup information with it onto tape. And then I would restore that tape backup to DC Nugget 2 in a location where it could be accessed locally. Now, both the backup and the restore must always be performed locally, so you can't access this across a UNC path or something like that. Now, on DC Nugget 2 then, I would simply go ahead and restore that database, at which point the DHCP service would start up again and we'd be back in business. One thing that's particularly important with that is that you go to your servers at that point, when you're in the properties in advanced, I would increase the conflict detection attempts to at least 1, because you want to make sure that there are not any addresses between these two DHCP servers that are inconsistent and that might try to get at least twice, depending upon the age of the backup that you restore to this other server. For example, perhaps this DHCP server here, we created a backup after 10.10.10.99 had been leased out. So only up to 99 is included in the backup. Then after the backup was made, 10.10.10.100 was leased out to a client. Now when we restore the backup to this server, it only knows about up to 99 in our DHCP leases. So it will try to lease out 10.10.10.100. And if we don't have DHCP conflict detection enabled, then it's going to try to do that, and it's going to have to create a little bit more network traffic because we're going to have to see IP address conflicts on the network. Somebody else on the network is going to get an error message that pops up on their screen. Going to cause a little confusion. We might have to do some reboots, so it's a little bit messier that way. Better off just to enable the DHCP conflict detection attempts. And so there's still a little bit of backup and restore that has to go on there in order to get this server back up and running. I guess it's more of a, not a hot spare, not a cold spare either. I guess it's kind of a warm spare as much as anything else. And then also you would, of course, make sure that this server, you would stop the service and that it was no longer available, so because you wouldn't want two servers simultaneously giving out the same addresses and causing potential problems. So after the restore, I'd stop this one. Or if it had gone down because of a hardware failure or something like that anyway, I guess that wouldn't be too hard to do. Now, let's go ahead and take a look at how we would do this. Now, I've already created a backup on DC Nugget 1 over here. And on DC Nugget 2, maybe I want to migrate it over, or I suspect that this server is going to have a problem. So I'm going to go to my Windows System 32 folder again. Guess I should have left that open the first time here. Go back to DHCP here then, and then the backup folder, I'm going to right-click here and choose Copy. And then I'm going to go to the UNC path to DC Nugget 2, so whack, DC Nugget 2 over here, and then I got a Windows directory here, but even though it's already got DHCP installed over here, and even though it already has a DHCP folder under Windows System 32, I don't really want to restore the database there because it will not restore properly from the exact same location. So I'm going to go to this temp folder and choose Paste. Now once I've done that, I'm going to go to an actual remote desktop connection to DC Nugget 2, and then I'm going to restore it from there, because remember, you can't restore over UNC path or something like that. I need to do it locally, so I'm going to be local at this remote desktop connection. Now once I'm into this, I'm going to go back into my own local file system on this server. So I'm going to right-click and choose Explore here. Go to my C drive, go to the temp folder where I'd restored this backup, and just confirm that I've got it, that I've got the right date there, that I've got the right information. Now, having done that, I'm going to go back to the DHCP server on this particular server here locally. And I'm going to right-click on the server and choose Restore, where I'm going to browse for my temp directory that I had earlier. And here it is, and there's my backup folder. I'm going to click OK, and it's going to stop and restart the service. Do I want to do this? Yes, I'll go ahead and do that. And then once I've done that, we're going to see that it brings this server back up, and it brings it back up with the scope and everything running. And there's the whole scope that we had. Here's the leases that we'd already leased out. Here's any reservations that we had. Now, the only thing I want to be careful of right now, and I could possibly do this even before I do the restoration, is to stop the service on the original server if it's still up and running, so that it won't get two servers that are simultaneously trying to lease out the same addresses. Once I stop it, though, of course, it says I can't find it because the service is stopped. In this nugget, we took a look at DHCP management and how to make sure that we have the proper redundancy in things such as the 80-20 scope, so that we can make sure that we still have a DHCP server available if one of the DHCP servers goes down. We also took a look at scope management so that our addresses are not depleted too quickly. We looked at some RAS solutions as well as how to use superscopes. And we took a look at the server properties so that you can designate where you want the DHCP database to go, which can be quite a busy database, and you might need to put that on a faster spindle. We also took a look in the server properties at Dynamic Update, which has several settings in several different locations, and we took a look at how that works. Then we finally looked at DHCP management, which talks about the DHCP database in terms of reconciliation in case there's errors or corruption in the database. The log files, which are a reflection of the database. We looked at how to back up the database as well as to restore it, which might be handy if a server goes down and you want to bring up a new replacement, or if you want to transfer the database to another server. And then we also looked at database compaction to make it more efficient. I hope this has been informative for you, and I'd like to thank you for viewing.